Silicon controlled rectifier is a power device mainly used for industrial applications. SCR is a three-terminal device, namely anode, cathode and gate. It is a unidirectional device. That means the current conductions takes place only positive to negative. Then it is a four-layer device, that is when you consider the diode model PN, it is a four-layer device. And also three junction device, say J1, J2 and J3, three junction device. And another very important thing is it is a switching device. That means once the SCR enters into the on state, it is acting as a closed switch. When it is in the cutoff region or cutoff state, then it is acting as an open switch. This is an equivalent circuit for the diode model of an SCR, that is from the outer p-type material we are taking a lead, we call it as anode terminal of the SCR. The outer n-type material we are taking a lead, we call it as cathode terminal of the SCR. Nearer to cathode we have another terminal, we are taking a lead from p material, then we call it as the gate terminal of the SCR. Here it is a diode model, two diodes are connected in series, PN. So that is two diodes are in series connection. Here there are two different operations are possible. One is when the gate potential is being 0, another one is when the gate potential is being given. When the gate potential is being 0, we are applying this anode cathode voltage to the SCR. Therefore, the junction J1 and J3 becomes forward bias, whereas the junction J2 gets reverse biased. So during that time, the minority carriers present across each and every junctions will constitute a very nominal current, that means a very low current. That current we call it as leakage current of the SCR. That current we call it as leakage current of the SCR. When this anode cathode voltage gets increasing, therefore slowly this J1 and J3 becomes more forward biasing. Once this anode cathode voltage will reaches the breakover voltage of the SCR, immediately the junction gets breakdown. Therefore, there is more number of electrons that are flow from anode to cathode. Therefore, there is a sudden increase in the current, but there is a reduction in the voltage, because the current will be gets increasing but the voltage gets decreasing. It is opposite. Ohm's law is equal to V by I, but here voltage gets decreasing but current gets increasing. Therefore, it is opposite to Ohm's law. That is why we call it as minus, that is negative resistance region. Then once it gets negative resistance region, up to a minimum point, the SCR will be always in the on state. That current we call it as holding current of your SCR. Then there is increase in voltage versus increase in the current. That region we call it as the saturation region of the SCR. I shall repeat it once again. When the gate potential is being 0, when you are applying this anode cathode voltage to the SCR, there is, due to the minority carriers present across the junctions, only a very nominal current will flowing through the SCR. That current we call it as leakage current of the SCR. That time the SCR will be remains in the off state. That region we call it as cutoff region of the SCR. Now once this anode cathode voltage increases, once it will reaches the maximum voltage of the breakover voltage of the SCR, immediately it starts, the junction gets breakdown. Immediately there is a more number of electrons that are flow from anode to cathode. Therefore, there is a heavy current can be flowed, but there is reduction in the voltage. That is why Ohm's law, according to the Ohm's law, R equal to V by I, but here voltage gets decreasing but current gets increasing. That is why we call it as negative resistance region. This is the minimum point that can be required by the SCR to maintain the on state, because it will never comes to the off state once it will enters in the on state. This is the minimum current required by the SCR to maintain the on state. That means there is a minimum flow of electrons always being there in the circuit. Therefore, then afterwards, then if you increase the voltage, there is increase in the current. That region we call it as the saturation region of the SCR. This as concerned about the when gate potential is being 0. When gate potential is being given, say for example we are applying a gate potential, say for example we are giving the gate potential starts maybe 1 volt, 2 volt, 3 volt, like that we are giving a gate potential is being given. automatically this J2 gets slowly increasing forward biasing. Once it gets forward, slowly gets forward biasing, this SCR will never allows to reach the breakover voltage. Before the point itself, it starts conducting. So once slowly when Ig is A, so before the point itself it starts conducting, then again like that. So it will, when gate potential will define the breakover voltage, will never reaches the breakover voltage to the maximum voltage. Slowly when it reaches, when increasing this potential 1 volt, 2 volt, 3 volts, 4 volt, 5 volt and all, say for example this may be 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt and so on. Therefore, once being gate potential is given, it will never allows to reach the breakover voltage of the SCR before the point itself starts conducting. Therefore, I can control the amount of power that is delivered to the load. Then the last point is rectifier is nothing but your conversion of AC to DC. This is as concerned about the diode model of an SCR. The same way, this is PN2 diode configuration. So that means, so we have, when you consider about the transistor model, PNP forms an transistor, another we have NPN form and another transistor. So this is the two transistor model of SCR. That means PNP then NPN. When it's combined together, it will form an silicon controlled rectifier. Let us we know how it works here. So when we are applying a gate potential, that means gate current to this SCR. So positive is connected to positive, negative is connected to negative. Therefore, the forward biasing condition of this PN junction will get forward bias. Thereby, this collector current gets increasing. So once this collector current gets increasing, slowly it will come here. So comparatively with this SCR, here what happens, this PN junction gets forward biased here. So once the forward biasing happens, this junction here, automatically this collector current gets increasing. So once this collector current comes here, automatically it come over here. So it will again forward biasing this SCR, this forward biasing this PN junction. Thereby this collector current will go. Therefore, if you giving only one time a gate triggering pulse to this SCR positive, so to this SCR, it will enters into the on state, it will never comes to the off state. It will never come to the off state until the anode cathode voltage becomes 0. Otherwise, we have to reduce the holding current below this level. So only the two conditions is occurred, automatically the SCR will be in the off state. That the first condition is, once the SCR will be enters to the on state, when you are giving a small gate triggering pulse to the SCR, always it will remains in the on state until the anode cathode voltage becomes 0. Otherwise, we have to reduce the holding current below this level. The SCR will be in the off state. So once when the SCR will be entered the on state means, once it will reaches the breakover voltage, it will reach the on state. So by applying a gate triggering pulse, I can control the breakover voltage at different points. Thereby I can control the amount of power that is delivered to the load.